Welcome to CloudSec with Subtletechie, your go-to place for bite-sized cloud security insights. Most people assume cloud breaches happen because of some elite hacker running complex exploits, but that's rarely the case. The truth is simple. Avoidable mistakes cause most breaches, and that's exactly what we're talking about today. Today we're diving deep into something that sounds boring, but can break an entire company, which is security misconfigurations in the cloud. Stick around, because I'm not just going to explain the theory. I'll show you real breaches, real mistakes, and how attackers turned them into millions. Dollar disasters. So grab your coffee or your notepad, because I promise after this video, you'll never look at your S3 buckets or IAM roles the same way again. First, let's break down what we mean by security misconfiguration. Imagine renting a brand new apartment but leaving your front door wide open. That's what a cloud misconfiguration is. It's not a vulnerability in the system. It's a user mistake in setup. Public S3 buckets, over-permissive IAM roles, unrestricted ports, and missing MFA. Cloud providers like AWS, Azure, and GCP give you incredibly powerful tools, but they expect you to lock the doors, set up the cameras, and build the fences. The cloud operates on a shared responsibility model. They secure the infrastructure, but what about the configuration, identity access, and storage security? That's on you. Malicious actors are not out here guessing passwords. They're scanning the cloud every single day, looking for these lazy setups. And with the speed of modern DevOps, misconfigs happen fast. One wrong line in a Terraform script or a missed checkbox in the console, and attackers have everything they need. Let's talk Capital One. In 2019, they suffered a breach that exposed over 100 million customer records. The root cause, an AWS IAM misconfiguration, allowed a former employee to escalate privileges and pull sensitive data using a misconfigured web application firewall role. That role had too many permissions, and no one was monitoring it. What made it worse is that this wasn't some obscure corner of the system. And the web application firewall role was meant to protect traffic, but it had permissions far beyond what was needed. That's the definition of privilege creep. The attacker used a simple script and got access to names, addresses, credit scores, and even social security numbers. Boom. Just like that. This attack cost Capital One over $80 million in fines and lawsuits, all from a role that should have been scoped properly and reviewed regularly. Next up is Facebook. A third-party developer stored 540 million Facebook user records in an unsecured S3 bucket. No password, no encryption, totally public. Anyone with the link could download user IDs, comments, likes, etc., all just sitting there. What's wild is that this wasn't a one-time mistake. At least two separate third-party apps had public-facing data tied to Facebook users. That means this misconfiguration happened repeatedly across multiple teams. Why? Because cloud storage was set to public by default, and no one changed it. You can't blame AWS here. It's a classic misconfiguration. And here's the kicker. AWS had already released warnings about public buckets years before this breach. But if your teams aren't trained or your config tools don't alert you, it slips through. Now here's one that really stings. Accenture, a top cloud services provider, they left backups of critical systems exposed in the cloud. That included VPN keys, credentials, and internal business data. Again, these cloud backups were on an S3 bucket that didn't require a password. Even worse, they were discoverable via a public link. If you clicked that link, you could see everything. This was a global tech company brought down by a misconfigured bucket. This was a wake-up call across the industry. If even a leading cloud services company could overlook basic security hygiene, what does that mean for the rest of us? It proves that no one's immune, and security audits can't just be checklists. They need to dig into real-world exposures. So, how do attackers actually exploit these misconfigs? Here are the top 3 ways. First, open storage buckets. Attackers use tools like automated scripts to find open buckets in minutes. Attackers scan cloud IP ranges looking for public buckets. Once they find one there, they dump the data or inject malicious files. Second, default or over-permissive IAM roles. Many organizations grant admin-level access just to avoid errors. Bad idea. And guess what? Some IAM roles are created by default with way too much power. Developers often use them for convenience, but they become a massive risk later. Attackers exploit those roles to escalate privileges and move laterally. Third, unmonitored endpoints with high privilege. This includes exposed admin consoles, open RDP ports, or unused but active credentials sitting in the wild. Think about abandoned dev environments, legacy apps, or ports left open after testing. Attackers love those. They're invisible doors into your cloud. These give attackers direct access into cloud accounts. Here's the truth. Most breaches don't happen because of a complex zero-day exploit. They happen because teams move fast, deploy fast, and, well, they forget to secure fast. Misconfigs come from rushed deployments, lack of security reviews, no automated checks, or just plain negligence. The cloud is powerful, but it's not plug-and-play secure. And when companies migrate to the cloud without a solid security strategy, they carry over old habits like manually granting access, skipping logs, or assuming their provider is handling security. In the cloud, it's only secure if you secure it. You want to stop this? Here's how. First, audit everything. Set up automatic scanning tools that run daily, not just once a quarter. Visibility is your first layer of defense. Use tools like AWS Config, Azure Security Center, or Wiz to find misconfigs in real time. Next, implement least privilege. In Azure, use PIM to give users just-in-time access. In AWS, use service control policies. Either way, no one should have admin unless they need it and only temporarily. Then, scan continuously. Use tools like Insight Cloud Sec, Wiz, or built-in CSPM tools to run regular config scans. Also, automate security checks. Policy as code with Terraform or Azure Bicep can actually block misconfigurations before they ever hit production. Policy as code isn't just a buzzword, it's your gatekeeper. Write rules once and apply them across every deployment. And finally, train your devs and admins. Security is everyone's job. Even non-security roles should understand basic misconfiguration risks. Regular internal workshops go a long way. Educate your cloud teams and test your configs often. At the end of the day, misconfigurations are low-hanging fruit for attackers. And look, no one is perfect. Even the biggest companies in the world get this wrong. But the ones that bounce back, they learn, they fix it, they build guardrails that catch these mistakes before attackers do. But they're 100% preventable. Don't be the next headline. Fix your configs, secure your access, and monitor your cloud. This is Subtletechie. Secure the cloud.